All right, transformations.
We're going.
Is that like shape changing?
Yes, except it doesn't change sizes. So, you did this in 8th grade, so obviously now it's the same stuff, it's just a little more advanced. There are 3 types of transformations. There are translations, which is just a slide. Put that away. There is rotations, which is a turn. And then reflections, which is a flip. So, a translation is just when you take something and slide it. It doesn't change like this at all. Rotation is if you take something and turn it. A reflection is going to be backwards. It's like when you look in a mirror, you see your reflection. Then what we do is we get into composites, which you do a glide reflection, which is called. It's just a slide, then you flip it. A translation, then a rotation. You slide it, then you rotate it, or you rotate it, then slide it. Rotation, translation. So that's the kind of stuff we're going to be doing. Now, all of these things, when you do a transformation, are called isometries. Isometry, you guys did isometric drawings, where you had the block and you had to draw the front, top, and side view. The reason why it's isometric drawings is because it's the same size. You had to measure the block, right, and make your drawing the same size. If something's in isometry, that means it doesn't change size. So all of these, they say, are translations is an isometry, rotation is an isometry, reflections is isometry. Because once you do it, it's not going to shrink it or make it bigger. Now these two, I think everyone knows what an image is. When you look in the mirror, you see your image, right? So the image is after the transformation. Now, I don't know why they use the word pre-image. Everyone knows what pre means, right? Before. I don't know why they don't just call it the original. But in the book, they call it the pre-image. So whenever you see a pre-image, that's the starting figure. The image is after it's been flipped or whatever. Okay? So in this one, when you have a drawing, here it's just a segment. Segment AB, and then here's another segment. Oh, I guess it's a triangle. There we go, ABC. And then here we have another triangle, ABC. Now it's kind of hard to see maybe, but this is just an ABC. This, you see the little tick marks there? That means, that's pronounced A prime, B prime, C prime. So whenever you see those ticks, that is the image. The ones without those tick marks is the original or pre-image. So you need to know that because you need to know where it starts and where it ends. In this picture, it started here and it moved here. So to name the transformation, is it a translation? Did it slide? Is it a rotation? Did it turn? Is it a reflection? It's a translation. They just slid it up. Now, to describe the translation, there's 2 ways to do it. The long way and the easy way. But you need to know how to do both of them.
Right up to the right.
If you just write it out in words, you do this just like you're plotting a point. It's not the same as slope, so don't think rise over run. It's just like doing points. To get, you can pick any point. To get from, I'll go from B to B prime. To get from there to there, I had to go 1, 2, 3, 4, 5, 6 to the right, and then up 2. That's one way to describe it. That's not the way you can do it in your assignment though. The short way of doing this is writing it like this, 6, 2. When you put these little marks in there, that represents a
That's how
vector.
you want us to write it?
That's one of the ways, yep.
Can you go 2-6?
No, because 2, 6 means you would only went over 2 and then up 6.
Oh.
So these are just like coordinates where it's an X and a Y. They're alphabetical. Shh, quiet. So it does matter what order you put them in. So again, don't get this confused with slope. Slope is the only thing in math that goes up first. Everything else, including this, goes side to side, then up and down. All of the points go over 6 and up 2. Over 6 and up 2. So when you write it like this, you use these brackets. That tells you, that's actually the brackets for what's called a vector, which we'll be doing later. And a vector is just directions, like airplanes fly in vectors to get from one city to the next city. Like if the city's here and they're flying here, they go directly to it, right? But the directions they give are over and up. So like if this goes over 90 miles and goes up 40 miles, this direction would be 90, 40. Okay? Does that make sense? Okay, we'll get to the vectors later, but that's the easy way to write it. Now, here's the long way to write it. And this is, I think it's called component form. To write a translation, they start off with this. X, comma, Y with an arrow. That just means move every X and Y as a translation. That's what the arrow means. You move X to the right 6. So when you go right, that's positive. And you move Y up 2, so that's a positive 2. So this just means take the X and add 6 to it, take the Y and add 2 to it.
So that's the other one?
Yep. This way and this way are two different ways to write it.
So would the bottom one be easier?
Yeah, much easier. They mean the same exact thing. But you need to know how to read these and write them. So all that is if you've got a point, forget about this picture right now. If you had a triangle where A was 3, 1, and B was 5, -6, and C was 2, 7, and they wanted you to move it and write the new coordinates, you don't have to graph it. You can just look at this. The new A is add 6 to the X. So that'd be 9. The new Y is add 2 to the Y. So everyone see how you get the new ones without graphing them?
Wouldn't it be, yeah.
Oh, 3, yeah. The new B prime would be 5 plus 6, 11. -6 plus 2, -4. And the new C would be 2 plus 6 is 8. And 7 plus 2 is 9. Okay? Now, if they do move left or down, then it's just minus. Same thing here. Okay, page got kind of bent here, but
Flip,
name this transformation.
flip.
Flip is correct, but it's not the correct word.
Reflection.
Reflection. It's been reflected. Now, this is the image up here because it's got the ticks. So this is where it started. That's the pre-image or original.
Mr. McKeever to the office, please. Mr. McKeever.
Rotation.
And this is, yes, a rotation.
Good job,
It's been rotated up. Now, to describe it, in this lesson, we're not going to get as technical as this, but in the next lessons, you're going to have to. To describe a reflection, you got to say, it's like when you look in a mirror, the mirror is the reflecting point,
Okay.
right? When you reflect this, if this were a piece of paper, if this were the original, and a reflection is you just fold it and it folds onto itself, where would you fold this piece of paper so they would fold on to themselves?
Horizontals.
Right here. So the way you describe this is it's a reflection, or you can just say reflect in. I don't know why they say in, I suppose it's because like you look at in a mirror, but it's the same thing as over the x-axis. That's how you describe it. So sometimes reflections go over the y-axis, so you just say reflects in the y-axis. Now rotations are a little tougher. This one rotated, I could either rotate it this way or this way, right?
Yeah, right.
Usually you gotta say what direction you go. The rotations we're gonna do are 90s and 180s. 90 degree rotation is what fraction of a turn? You guys, why don't you put your iPads away? It's a fourth of a turn. So if I rotated it up to here, it would be a 90 degree clockwise.
Is that how you'd state it?
Yep. If I'm going from here to here. If I went 90 degrees counterclockwise, it would end up over here. But now this is a half a turn, right?
Yeah.
So a half a turn is how many degrees? 180. And since it's 180, it doesn't matter if you go clockwise or counterclockwise. Now there's one other thing. You don't only have to name the degree, you gotta say what it rotates around. It's like if you had a string and held something tight and then you rotated it, this would be the point that rotates around.
Okay.
Make sense?
You don't have to do that yet, right?
Not yet, yeah. These are the toughest rotations are, just to warn you. What this would be is if you connect all the points
Okay.
from C to C prime, A to A prime, and B to B prime, where they all three intersect is the point that it's rotated around. So what point is that on a graph that you'd call it?
Origin.
The origin. So they don't say around the origin, just like here, they don't say over, they say about the origin. Most of the stuff we do will be rotated around or about the origin. And then again they ask, are they congruent to each other? Yeah, they are. They didn't change sizes, they just moved. So, these are easy. Do these appear to be in isometry?
No.
No, they're different sizes.
Yeah.
Yes,
Yeah.
yes. Okay, it's kind of bent here, so it looks like it's turned up, but this has just been a translation. It's just slid down. This one has been a reflection, yep. So today, all you gotta do is name them. You don't have to describe them. So here they've got a reflection. They call another way of saying it is it's mapped onto it. JKL is mapped onto MNP. That means this is the original and this is the image. Mapped onto it just means it's been moved to it. So if this is 48, what's this? Right. And this is 78, so that is. This is 12, so this is 12. This is 9, so that's 9. And then we could figure out what this angle is, just subtract those off of 180. Okay. Does this appear to be an isometry?
Yes.
Yes. In the assignment, if I forget to tell you, you don't need to explain. If you did, you just say it's the same size. So here we gotta find XZ. ABC is mapped onto XY or XYZ. It's just been rotated. So it's the same as that, it's 17. And angle Y is the same as this one. It looks like it's 90, right?
I say so.
54 and 36 does add up to 90, so that means that's 90. So, it's pretty easy. Let me put it up on the board.
I was just dozing off 5 seconds ago.
Why?
Cause I'm tired, that's why.
You should have stayed up all night.
Yeah, I was still up all night.
Yes, you did.
No, I didn't, I actually went to
I
bed
saw you.
early.
I saw it. How rude. I don't know what time you go to bed. Pretty decent time.
And I woke up at 6.
I went to bed pretty, I was like 10:55. You like, you have like longer. Yeah, I always do. I do too, actually. It's the way I lay. I don't use my pillows. I sleep on my head.
Oh, yeah, I gotta send that, don't I?
I used my blanket.
Look, you can try it.
I literally just wrapped myself in a blanket.
Don't you sleep like this?
Yeah, like that. Sometimes I use the pillow under my arm.
What chapter is this?
Chapter 7, I gotta send it to you.
Oh.
So, we'll just go through a few of these up here before I send it to you.
Alright. We're gonna go through.
Okay, the first ones, 5 through 7. Name the transformation that maps the blue pickup,
Okay.
so that's the pre-image, onto the red. So what did they do here? Translation.
Oh, that's right, we have to do
Like abbreviate it, like trans.
No.
That's what I'm thinking.
Slide is the elementary rule. I don't know why they don't teach you that in elementary. Translation is what it's called. This one, reflect.
It drives on its roof.
You could just put translate. You don't need to put translation, I guess. And this one, rotate. The way, if you're not sure on some of these, you can eliminate. If it doesn't look exactly the same, then it's not a translation. And a rotation, you could turn your book and it would eventually look exactly the same. A reflection, if you turn your book, it's always going to be backwards. Reflections are always backwards of each other. So that's one way you can tell. Okay. So on here, you just got to look at this picture. I want to point out on 21 and 22, name and describe the transformation. You don't need to describe it like we did, just name it. And then remember, name the coordinates of the image. So it shows an arrow which way it's going. So this is the original, this is the image. So you got to say, since this has been flipped, this is B, A prime would be there, B prime would be there, and C prime would be there. So you got to list the coordinates of that. Okay?
We'll come.